Alright, so we are now fully reacted. If you look closely, you can see that the marble chips have as much as been dissolved as possible. So we're now going to decant this liquid, which means to just pour carefully without losing any of the solid. Then we want to rinse. Get rid of any acid residue, although there shouldn't be much, if any. And rinse it second time. And then we want to dry the marble residue back on the hot plate. Which is another point where we can pause it. You can work on the post-lab questions, or through the magic of video we will just pause it, because if there's anything more boring than watching marble dissolve, it's watching water evaporate. Woo! Okay, so it is fully dry now. So what we need to do is take it off the hot plate and allow it to cool. Again, another boring wait time. So through the magic of pausing, pause, and it are cool. So now it is cool. Put it on the scale. 110 point, oh my goodness, okay. I'm going to turn this off. Turn it back on. $110.5655. 110.55. Pause. Okay, we now have all of our data. This was our initial weight of the beaker. This was the beaker with the 15 large marble chips. This is the weight of the beaker with the marble that was left over after the reaction. So if you subtract these two, we get the mass of the marble, the original marble. If we subtract these two, we get the mass of the marble that's left over. And then if we subtract these two, we get the mass of the marble that was eaten away by the hydrochloric acid. Now we'll flip over to the back and I will show you how to do the calculations to find the volume used and the concentration used. Oh, you're filming? All right, so first we need a balanced equation if we're going to be doing stoichiometry. We reacted hydrochloric acid with calcium carbonate, and we produced water with calcium chloride, and the bubbles were carbon dioxide. And then since there's two hydrogens and two chlorines, we need a 2 in front of the HCl. Now, if you remember, we diluted the acid. We started with 12 molar HCl, and we used 10 milliliters of it. And then we don't know the new concentration, but we made 100 mils of it. And then if we solve for M2, we get a 1.2, so we diluted it 10 times. So we went from 12 molar down to 1.2 molar. Then if we go to our original molarity equation, we can figure out the number of moles. We know the molarity, we know the liters that we used, so we can find the number of moles. The molarity was 1.2 molar. The number of liters was, you remember we only used 25 milliliters, which would be 0.025 liters. And then if you solve for moles, you get 0.030 moles of HCl. Now we have to convert moles of HCl to grams of calcium carbonate that can be dissolved. So we take the 0.03 moles of HCl, we convert it to moles of calcium carbonate. We see the mole ratio is 2 to 1 or 1 to 2. So for every 1 mole of calcium carbonate, it takes 2 moles of HCl. And then the FMG of calcium carbonate is 100.1. Multiply that out and you get 1.5 grams of HCl. Okay, so now we have two pieces of information we can add to the front. Our concentration of acid, was 1.2 molar, and the volume used was 0.025 liters. Okay, now going back to the other side. Calculate the experimental mass of calcium carbonate that was removed. We take the 5.66 minus 4.18. And we get 1.48 grams of HCl. Nope. Calcium carbonate. And this should be calcium carbonate also. So right away we can see we were very close. So our percent error, if you take 1.50 minus 1.48 divided by 1.50, we get 0.02 divided by 1.50, and that comes out to, pause, okay, which comes out to 0.0133, which equals 1.33%, which is not too bad for Saturday morning in the face of certain death in the COVID shutdown. Just kidding. You're all safe. Just stay at home. Hope you enjoyed that. Good luck with the further calculations, and I'll see you in the next lab.